All right, guys, welcome to another episode of CUDA Education. Again, if you guys want to join in on the fun, you definitely need to get tutorial number 1, which installs the Vulkan SDK, guides you through installing the Vulkan SDK, and tutorial number 13, which is guiding you through installing these examples that you see over here. This assumes a Windows-based machine with a Vulkan-capable GPU. Now, if you want to be able to run the ray tracing examples, you need to make sure that you have a ray tracing capable GPU. And in the case of NVIDIA, you need to have RTX GPU. The RTX GPUs allows you to run the ray tracing stuff. Ray tracing has been the rave last couple of years, or less than even couple, but it's photorealistic sort of graphics and all of that good stuff. So I am working my way through learning this stuff, and I still believe that the best way to do it is to look at working code and try and follow, or figure out using information and the spec and everything to figure out what's actually going on. So here we have ray tracing basic. When we run it, we get a ray traced triangle that basically is a triangle via the ray tracing approach methodology. Obviously, with this triangle, you're not necessarily gonna see any great difference between this and like the normal way of generating a triangle. But for those of you that are in the video game world, you definitely know the difference between regular graphics and ray traced graphics in terms of the quality and the photorealistic quality of the graphics and stuff. All right. Um, so yeah, I think the best one of the things that the overall thing about this ray tracing stuff is that you want kind of a roadmap of what's going on. It's it wouldn't really be smart to just be diving into code and like random topics and ideas, and you don't really know what you're looking at or why you're looking at what you're looking at or what the context is. You need like an overarching sort of bird's eye view of everything, and then you could dive into specific regions or specific topics, right? So the best thing I could have thought of, or the best thing I thought of was, okay, Vulkan ray tracing pipeline. Okay, so this is Google Images, and they have all these things about the ray tracing pipeline. Um, the Conus group is very cagey about, they don't want people like going into the spec or showing the spec willy nilly and all that stuff for good reason. And I plan on respecting their wishes and what have you. Um, but but I did want to show this diagram, and this diagram is sort of, it's supposed to help us to sort of understand how this all works, right? And I'm not really going to get into the particulars of the line of logic right now, but this is basically what the ray tracing pipeline is, and this is what the code here is supposed to be doing in order to generate a triangle. All right, so we have ray generation, we have an acceleration, structure traversal, we have intersection, any hit. I guess all of this, circles back into the acceleration structure. And then you have, a question of whether there's a hit, closest hit, or a miss, right? Now, I'm not gonna get into to these things right here. The only thing I would say is that I have been like I said in my previous video, the acceleration structure is supposed to be a sort of pre-processed blueprint of the scene, right? So Um, the text mentions to achieve a high performance on complex scenes, ray tracing performs ray intersections against an optimized data structure built over the scene information called an acceleration structure. Okay, so let me repeat that. So basically, your ray tracing performs ray intersections against an optimized data structure built over the scene information called an acceleration structure. And then you get into to different there's a two level hierarchy to this acceleration structure. The lower level hierarchy, or called the lower level, bottom level acceleration structure, and then there is also the top level. This says a lower level um, bottom level acceleration structure contains the triangles or axis aligned bounding boxes. This AABS, axis aligned bounding boxes of custom geometry that make up the scene, right? The upper level, the top level acceleration structure contains references to a set of bottom level acceleration structure. Each reference including shading and transform information for that reference. So okay, so let's start with the bottom level. Create a bottom level expression contains the scene's actual geometry, vertices, triangles, right? So we kind of went through this yesterday, but let's do it again, right? So the bottom level structure basically has the triangle with the different vertices in them, right? And then the top level, so right, the spec says the upper level, the top level acceleration structure contains references to a set of bottom level acceleration structures. So I guess this is where you're talking about instance, so maybe one top level can refer to several bottom level acceleration structures, right? Um, that's sort of the gist of what I get from it. Um, and then we get into all kinds of different variable types and all that stuff, right? So I mean that's just what I wanted to sort of investigate right now. So yeah, let's just hang out with this code and see what's going on. Okay. All right, so we have ray tracing acceleration structure here. All right. And then we initialize the top, bottom level and the top level acceleration structure. All All right, create acceleration structure buffer. In the spec, it does talk about it does talk about how the acceleration structures have a big memory footprint, and there's a thing called compaction of the acceleration structure to make it more efficient, um, and remove excess things to optimize sort of the application. And you could create acceleration structures on the CPU and on the GPU, but like you have to be careful about how you do this and where you do it and how you manage the management of doing it, and how you know um bring it over from the CPU to the GPU. Like you could parallelize things and all of that. So this acceleration structure is actually a really big deal. um all right, so we're creating a container for it. Um, right. So of course the bottom level, as I said, gets into the actual triangle, right? And then of course you know, we have to be careful what kind of memory we're using for it and who can access that memory. All right. Yeah, I haven't even gotten into like the build of it, right? Because that's kind of the hard part of it too, is the build of the acceleration structure. So um I'll have to get into that. That'll be a discussion for another day. um I want to see. Create acceleration. So okay, so we have our um right, so we have our create acceleration structure function. Acceleration structure build size info. Okay. So this is a function, and then we use it to do the bottom level, right? We use it to do the bottom level one, acceleration structure build size info, right? So I guess, right, two parameters. The um the acceleration structure, and then the build size information, right? um right, so we do it for the bottom level and the top level. Okay, makes sense. We expected that. um just want to see. I want to see what's going on here. I want the earliest. Okay, right. So we had declared the let's say the top level acceleration structure. We're declared this thing here, right, at line 49. And then, all right, that's just the destructor. We don't care about that right now. Okay, and then we do create acceleration structure buffer. Okay, so we call that at line 454. um Oh, we always got to have a create info, guys. We always have to have a create info. Come on. What do you think was going to happen? You think you're not going to have a create info? This is Vulkan after all. So anyway, there's a create info. Accessory structure create info, right? So we're passing this guy. Oh yeah, now we're getting into the build. DST, destination, right? So if there's a destination, there has to be a source, right? Oh no. Okay, so create a small use to during build of the top. Okay, so we're not gonna get into that right now. And then there's this device address conversation. All right, let's all right, let's just see if we could kind of make sense of in a very basic way, but at least kind of get some line of logic stuff going on. So we initialize the top level acceleration structure just like as a variable name, right? No big deal there, right? So let me be creative now, right? So if I do something like this, I wouldn't break anything, right? I'm just messing with you guys. I'm not gonna do this right now. I'm just messing with you guys. But just understand that CUDA education is official, and we are acceleration structure. Okay. Anyway, all right. So all right, let's get some line of logic in all seriousness. All right. So all right. So we initialize a variable. Um, we create acceleration. So we create a buffer for the acceleration structure. Okay. Kind of follow that. Uh, okay. Yeah. Okay, this VK create acceleration structure KHR. All right, so let me see what this is actually doing. I'm actually just gonna drop that into Google. Right, so this is the spec says is basically the opaque handle to an acceleration structure object. So I know anytime you have like a function with like lowercase vk, it's actually very powerful and important. So I think this is probably where we actually create the real deal Holyfield, right? Where you actually create the um the top level acceleration structure, right? You know how Vulkan goes. It's a whole bunch of like create info stuff, and you gotta put in a bunch of hieroglyphics and things like that, just to so that when you call the lowercase vk function, that and you're actually doing something in Vulkan, that everything syncs up properly, and you get it right. Okay, so I believe this is super important, and this is probably what we're what actually creates a top level acceleration structure. Okay. All right. Yeah, destination acceleration structure. All right, so this is can't really speak on this. Don't really know what this is yet, but that's all right. And then there's the device address stuff, which um okay, let's see what the author has to say. Build the acceleration structure on the device via a one-time command buffer submission. Some implementations may support acceleration structure building on the host, but we prefer device builds. Okay, so that's that. And then, yeah, you get into the device address and blah, blah, blah. So, you know, d- 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 doing the build on the GPU versus the CPU. Remember, guys, the host is the CPU and the device is the GPU. Okay, so I guess that's what this content, what he's referring to here. But we're not gonna get into that right now. All right, what are we doing here now? All right, create descriptor set. So I know that a descriptor set is you're trying to describe something in memory. It's a USB stick, but you're labeling the USB stick with whatever is on the USB stick, right? So this guy right here is right, create descriptor set used for ray tracing dispatch, right? So we'll have to, investigate this some more. All right, and then we're back to square one. So I'm gonna guess then that the other bottom level acceleration structure is gonna be the same kind of line of logic, right? So it shouldn't be anything too different from what we just went through. So let's go. All right, bunch of destructor stuff, which will I'll make sure I get into later. Create acceleration structure buffer. Okay. Um. Right. We saw that. Right. We saw this before for the other one. Right. Again, we have our lowercase vk function, which actually does the thing in Vulkan. Like everything else is just kind of typing stuff and like putting things together and referring to stuff. But this lowercase vk thing, anytime you see a lowercase vk in Vulkan, like a lower vk function, you kind of know that like it's something actually happening. Um, right, we do have this destination acceleration structure thing again. Need to put some energy into that. Okay, right. We're building again. Blah blah blah. I want it to be done on the GPU slash device and not the host slash CPU. Right, so that's that. We have our device address thing. Aha. Okay, so this let's just go back. Okay. So notice that the bottom level acceleration structure is referenced by the top level acceleration structure. So in the function create top level acceleration structure, we see that we have a reference to the bottom level acceleration structure dot device address, right? But I'm not going to get into device address, okay? So we see we have a reference to the top level is referencing the bottom level, which is sort of what was mentioned in this in the when I was talking about what the chrono spec outline. Let me see if I could um, pull it up on my end again, right? Because we're just cool like that. Okay. Okay, right. So in the spec it says something about it says the upper level, the top level acceleration structure contains references to a set of bottom level acceleration structures, each reference including shading and transform information for that reference. I know I just said references like 10 times, whatever, but I'll just repeat. The top level acceleration structure contains references to a set of bottom level acceleration structures, right? Let's just leave it at that. The top level acceleration structure contains references to a set of bottom level acceleration structures. That's what was outlined in the spec. Okay, so um, this top level acceleration structure um, this top level acceleration structure, you see, create top level acceleration structure. It references the bottom level acceleration structure. So as part of this instance thing, it's referencing bottom level acceleration structure. Now, you will notice that um, it doesn't go the other way around. Like, I don't think the bottom level acceleration structure was referencing the top level, right? Because, of course, that we wouldn't expect that, right? Based on what the spec is saying. So, you know, this is our little reference here that we that at least we have some context and some grounding for what the spec is talking about, right? So it's referencing it here. And that's pretty much it. I did want to go over the destructor stuff. Okay, so let's so you create stuff and you destroy stuff, right? So remember, now you're always destroying things. You always, whenever you create something in a system, you want to make sure you destroy it, because you want to free up memory and free up your RAM and free up just resources and all of that stuff, right? Because, like, if this application was to run forever and ever, um, and you're not freeing things up, eventually the system will crash, because you'll be eating up RAM, you'll be eating up memory. Your system will become unstable. You maybe would use something like virtual memory or something like that, but that eventually will run out too, and then you'll crash your system, right? So I always give this example. I've said it again in several other videos. But in space there was what I heard. I think it was in some magazine or something I was reading way back. But they were saying that they would pay millions of dollars to a vendor or a private company. I think it was NASA will pay millions of dollars to a private company that could guarantee that their application to do something important and special in space, that they would pay millions of dollars to a firm that could write an application, or give them some software that would guarantee there are no memory leaks, right? Memory leaks being that you're creating stuff, you're consuming memory, but but um but then you don't free it, and therefore it's a memory leak. Because once you create the thing and you use the thing for what it's used for, and then it's not destroyed, um it's as if the memory is leaked, or it's wasted, or it's thrown in the garbage, right? And of course you're dealing with space and all that stuff. So You create stuff, you have to destroy stuff. So this is good housekeeping. Okay, so for the bottom level acceleration structure, you know, we have to make sure we're destroying. Oh, it's also called garbage collection too in like software speak, garbage collection. Right? So you're freeing up the memory, you're freeing up the buffer. What else? And I guess you're freeing up the acceleration structure itself. Okay, so memory buffer acceleration structure itself. I guess top level will be the same thing, right? Memory buffer, the acceleration structure itself, right? And you see you have this VK, the VK destroy acceleration structure KHR. Okay, so that's pretty much that. One other thing that I wanted to mention is that okay, so these guys, you're just this doesn't really do anything. I've seen this in Vulkan many times where all this is doing is you're initializing a variable, right? And it doesn't really mean anything. It's just like you're initializing like a type of a variable, but it doesn't have any substance. It doesn't have any processor meaning, processor procedure, or nothing. It's just a variable of type acceleration structure named bottom level AS, right? A variable of type top level of type acceleration structure named top level AS, right? This doesn't do anything. You're just creating a name, right? But that VK stuff, when you start getting into the VK stuff, is when come on, you start getting into the VK stuff, right? When you start getting into the VK stuff, the lowercase VK, this, well, this is destroying them, but right, this guy is a real deal, right? So just keep that in mind. I think this is enough for this video. I don't want to get too much more into it. The spec just it just goes off the deep end of the ocean, right? It's like all this other information, but at least at this point we have an idea. We're not totally scared about acceleration structures. We know that there's a thing called acceleration structure, which basically deals with um this part of the equation. We generate rays, and then the rays are supposed to traverse the acceleration structure, and the acceleration structure um is some kind of optimized data structure. Okay, so I'll just repeat. Ray tracing performs ray intersections against an optimized data structure built over the scene information called an acceleration structure. Okay, so we're basically shooting rays over this acceleration structure, which is a optimized data structure, with information from the scene, right? So you know we might see a scene with our eyes, but digitally, like computer wise, a computer only sees ones and zeros. So maybe the acceleration structure is ones and zeros, and what we call a scene is like what we see with our eyes, right? Like a room, or like a room with a table, or you know um a landscape or something. Okay, so right. So we have our acceleration structure. We have the bottom level acceleration structure, and we have the top level acceleration structure. And we know that um, we know that the bottom level acceleration structure is like the more granular is the vertices and stuff. And then the top level acceleration structure um, has references to the bottom level acceleration structure. Okay, right? And remember, we had our reference to the bottom level from the top level, because in the instance under the create top level acceleration structure function, we had this reference instance.acceleration structure reference. So we reference the bottom level acceleration structure with this, with this declaration right here. All right. So um, I think we made some progress today. I don't want to get too much more deep into it, but this script is slightly less intimidating to us, and we could try again tomorrow. All right. So lastly, guys, if you want to be able to run these scripts on your Windows-based machine with a Vulkan-capable GPU, you need to get tutorial number 1 and tutorial number 13. All right. I made sure today to have the mouse enabled so you guys could follow along a little better. All right. Um, ray tracing is, well, listen, computer graphics in general is a lot of moving parts, right? There's no way you're gonna get this stuff down pat overnight. All right. It's consistent effort over a long period of time, and just trying to make sense of um all the moving pieces, so that you could follow along and eventually start building your own stuff, right? So that's my approach, and I believe it works quite well. So uh want to thank Sascha Willems. Whether we agree or disagree, just want to thank you for these examples, um, and hope that you have some patience for the rest of us, um, as we try and learn this stuff the best way that we can. Um, yeah, so it's a lot of good examples. So definitely, guys, it's well worth your time to get these examples installed on your machine. Yeah, that's pretty much it. I don't really have much more else to say. CUDA education, guys. Tell your friends. I think maybe you should get your friends to follow along with you these videos and like make some progress. Being able to do computer graphics, especially for young people who are artistically inclined, it it's well worth your time, right? But nothing comes easy. It takes time, energy, effort over a long period. I've actually been kind of at this Vulkan stuff for quite a while now, and I'm still fairly new at it, because it's just there's always new things. I mean, that's the nature of computer science. Anyone will tell you who's a programmer in the industry that um the blessing and the curse of the industry is that technology is always changing. It's always updating, and there's always new stuff. And you have to make sure you keep up with it, right? So I'm not gonna go. I'm not. I try to just cut to the chase, right? And carry you guys along with me, and we learn this stuff. All right, guys, thank you for watching. Definitely check out my other videos. um Many videos. I have a lot of free videos too, so you could watch those if you're thinking about getting the tutorials and installing stuff. Feel free to watch the other free videos. I have a lot of other free videos, and that will kind of give you an idea of how I teach, how I do things, how I walk through things. And then you'll be more comfortable to make a decision as to what you want to do. I do plan on making, some more videos about Vulkan in general, not necessarily ray tracing, but ray tracing is where the world's attention is right now, right? And yeah. All right, guys. Thanks for watching. Have a great day.